In 1976, a catalogue entry was made. A faint red star in the constellation Scutum. Reference number, Stephenson 218. The astronomers who wrote it down moved on. They had hundreds of entries that night. Here is the question that entry raises, and that nobody asked for 40 years. If you stood on the surface of Stephenson 218 right now, what would you see? The answer will require us to first understand what that surface actually is.
For most of human history, the stars were fixed. Not literally. We know now that every star moves, every star ages, every star eventually fails. But to any person standing on Earth and looking up, the sky appeared permanent. The stars were reliable in a way that almost nothing else was. They were the one part of the universe that seemed to stay. When astronomers began cataloguing stars in detail, they found something that preserved that sense of order. Stars come in sizes, but those sizes have limits. There is a floor, a minimum mass, below which an object cannot sustain the nuclear reactions that make it a star at all. And there appeared to be a ceiling. That ceiling was thought to sit at somewhere around 150 times the mass of our Sun. Above that threshold, a star's own radiation, the light and energy it produces, pushes outward so hard that it begins to tear the star apart before it can fully form. The physics imposes a boundary. Measured, documented, accepted. For decades, the largest known star was UY Scuti, also in Scutum, the same small region of the Milky Way. Measured at approximately 1,700 solar radii, that number stood as the record. Astronomers had a ceiling, and they had measured it. In 1976, Charles Bruce Stephenson published a catalogue of stars near the galactic center. Entry number 18 in his second list sat in a dense, dust-obscured stellar cluster, a region so packed with gas and debris that infrared telescopes were required to see through it at all. Nobody looked closely enough to measure it properly. When they did, decades later, with instruments Stephenson did not have, UY Scuti quietly lost its record. Not narrowly, not by a marginal revision, by 450 solar radii. Stephenson 218 has a measured radius of 2,150 solar radii, 2,150 times the radius of our Sun. Before that number can mean anything, we need to establish what our Sun actually is. Think about the distance from the Earth to the Moon. Roughly 380,000 kilometers, a number large enough to be meaningless on its own. But if you were to drive that distance at motorway speed without stopping, it would take you approximately 6 months. Our Sun's diameter is 3.5 times that distance, 1.4 million kilometers wide. A star so large that 1,300,000 copies of Earth fit inside it. A star that has burned continuously for 4.5 billion years. By any human measure, enormous. Stephenson 2-18 is 2,150 times that size. Place it where our Sun sits. Its surface does not reach Mars. It does not reach Jupiter. Its surface extends past Jupiter, past Saturn. Every spacecraft humanity has ever launched toward another world, Voyager, Cassini, the Mars rovers, New Horizons, every one of them would have been flying through the interior of this star. Not past it, through it. UY Scuti, the previous record holder, the star that had defined the upper boundary for decades, fits inside Stephenson 218 with room remaining. Room equivalent to hundreds of solar radii. The new ceiling did not revise the old one. It made it structurally irrelevant.
In part 2, what this star actually is, what you would see if you stood on it, and why it cannot last. This is Infinitum Space.